CO4. Today we're going to be talking about Pet Analyze, Pedestrian Behavior Indicator, and Ontology. My name is Ritvik Bansal and I'm from North Creek High School.
My name is Misha Gadni and I'm from Cupertino High School.
I'm Isam Jubair, I'm from Notre Dame College, Dhaka.
I'm Ishmeet Singh and I'm from Stockdale High School.
I'm Sueda Salimi and I'm from Gymnasium Ehsan Chowdhury.
Our mentor this year is Dr. Mukhtir, who's doing So first we're going to talk about the table of contents. So first we're going to give you guys some background, then we're going to talk about the annotator tool Pet Analyze. Then we're going to go into our data set, future work, and then end it off with the conclusion. Starting off with the background. So as you guys may know, self-driving cars are becoming really popular. Since 2018, we've seen almost a 5 times increase in the amount of self-driving cars on the roads. However, these self-driving cars model pedestrians as somewhat ideal people, but as we know, pedestrians are actually very unpredictable and they're not ideal. And so this poses a challenge as self-driving cars may not be prepared for such unexpected scenarios, as you guys can see in the GIF below.
So to address these challenges, we targeted several key ideas. The first of which was ontology, or the structured framework that categorizes and within the categories defines these different pedestrian behaviors. And as essentially a classification method with definitions, it establishes a standardized terminology. But why exactly is this so significant? Despite there being numerous advancements in AV literature in the past couple of decades, there is currently no existing ontology to our surprise. So there's no specific existing literature analyzing pedestrian behaviors in this standardized manner, which is the huge need for this project. So the way in which the ontology works starts off with reviewing images and videos, literature, as well as trajectory data sets. And once we've reviewed these incidents, we identify unique behaviors and conditions. Then we ask ourselves the question, do we have the existing terminology to properly define and describe the situation? If so, we can simply annotate and store the scenario. But if not, we define the new term and categorize it, adding it to our new ontology to generate this, to further our data set. And by annotating and storing this new scenario, we aim to cover nearly every incident with this method.
Another key point after ontology is for sure the behavior. But first, we need to know what is a behavior. A behavior refers to actions that pedestrians and vehicles take. Usually, behaviors are classified into 2 groups: behavior of pedestrians and behaviors of vehicles. Firstly, we have behaviors of pedestrians, which encompasses the various ways individuals move and interact while walking in public places, while the behavior of vehicles involves the various patterns and responses that interact with other road users. In the images, we have a behavior of pedestrians, which we recently discovered, and we're going to be talking about that in detail later. Right now, we have an example of vehicle behavior, which is the sidewalk. As we can see in the photo, the sidewalk vehicle behavior describes cars that drive onto the sidewalk and may cause a collision, like the one we see in the photo.
And just like Suela mentioned in example vehicle behavior, we also have an example pedestrian behavior. And my favorite novel one, the car hood hopper. You see, this pedestrian happens to be so impatient that he's willing to climb onto the hood of the car and then jump off in the middle of traffic just to get to his destination a little quicker.
Moving on, we have the archetypes. So what is an archetype? A pedestrian archetype is a composition of behaviors that uniquely identifies a specific personality of pedestrians, like drunk pedestrians, distracted pedestrians. In general, archetypes are used to categorize and analyze pedestrian behaviors, significantly simplifying complex patterns into recognizable types. So what are the importance of archetypes? Archetypes give us the unique type of pedestrians, and archetypes are communicable. It reflects the public concerns, and archetypes bring together the research and testing gaps. So what is the connection between archetype and pedestrian behavior? In the left side, we can see some pedestrian behaviors, which are using phones, listening to music, interacting with other pedestrians, and looking away from the traffic. So if any of these or many of these behaviors are seen, we can identify the pedestrian as the distracted pedestrian, and here's the archetype. Here we have two more examples of archetypes, the flock and the corner artist. The flock are mainly a group of pedestrians. They are dangerous when they do not precisely move together and cause chaos. In this picture, we can see a woman was moving with her two kids, but she left her kids in the driving lane and was late for the car to move. In the second picture, we have the corner artist. The corner artist is a type of pedestrian who intentionally stages collisions to claim their compensation from the insurance. So in this picture, we can see a pedestrian standing in the middle of the driving lane and creating a fake accident.
So now that we've delved into both the ontology and archetypes, let's examine the exact difference. So the ontology represents the way to classify these different behaviors, or a framework of behaviors, with categories and behaviors underneath each one. On the other hand, archetypes, as S.M. Jubair mentioned, are a series of consecutive behaviors, or basically a series of behaviors.
So with annotations, we can now look at these behaviors in real life scenarios. So annotations are basically highlights of key behaviors in videos, and these annotations include pedestrian behaviors, vehicle, environment, and archetypes, which we previously mentioned, and they occur in parts of the video. And together, these annotations create a data set. So a data set is a structured collection of annotations, and in order for an annotation to be added to the data set, all portions of the video have to be annotated. And a data set allows the user to easily see different distributions of archetypes and behaviors, as you can see in the table below.
So as we continue our presentation, we're going to be mentioning the word simulation a lot. But what really is a simulation? You can think of a simulation as somewhat as a game that self-driving cars play, in which the pedestrians are the obstacles. So as the car plays the game, it learns how to navigate through the pedestrians safely. And this simulation essentially allows cars to play the game online instead of, getting tested in the real roads where they could potentially hurt real people. The issue is, however, the simulation/games that self-driving cars are currently being tested on are not a real representation of what pedestrians are in the real world. So that's essentially our goal. And so kind of wrapping this up, how is everything related? So we have an ontology, which is the framework of archetypes and behaviors. Archetypes are composed of behaviors, like Ishmi mentioned, and all of these relate to the annotations you make. The data set is composed of annotations, and the data set is also used to create the simulation.
So this leads us to the next question, which is how can we create the simulation? And the answer to this is that we need a tool. So in order to create these annotations, our tool needs to be able to analyze and document different behaviors that we see in real world scenarios. And so we need to be able to create annotations from the tool. And currently, there are a lot of dashcam compilations that have these real life behaviors, but YouTube does not have a functionality that allows you to directly annotate the videos. So with our annotation tool, we need to be able to annotate these videos and create a data set which will then allow us to look at the behaviors and figure out which ones are necessary to incorporate in the data set. And so this leads us to PED Analyze, which was the annotation tool that we created. And like I mentioned, PED Analyze is a web annotation tool that's designed to produce data sets from annotated YouTube videos. And so we had originally coded this using Python tkinter. However, it proved to be really slow, laggy, and was ultimately not an optimal option for the graphical user interface. And so we switched to a web tool, which was a lot faster, and it allowed us to add more features and make it customizable.
So when you first open PED Analyze, you're greeted to the home page where you can insert your project name and a video link URL. You can create multiple projects, as you can see under the past projects category, allowing you to work on multiple annotation and videos at the same time. You can also download the JSON data, which is how we're creating our data set, and you can even delete projects.
So when you open a project, it prompts the user to this main annotation tool screen. And one of our primary features in this screen is our video navigation. So when the user opens a project, they're prompted to enter in YouTube URL. And when you open the tool, the Video Navigation Center opens the YouTube video, and it has a control center, like you see on the bottom, where it allows the user to navigate throughout the video. So this means the user can select a specific portion of the video to focus on, or jump forward a couple seconds or backward a couple seconds. And it's also where the user can select a portion of the video to annotate. And our next feature is the actual annotations. So as I mentioned, when the user navigates to a specific portion of the YouTube video, they can add predefined tags to annotate the videos. And these tags are taken from the ontology, which Ishmeet talked about. And in order to make it easier for the user to add these tags, we also have a search functionality on our annotator tool, and this allows the user to search through and filter the tags based on categories, synonyms, and similarities of words. And this leads us to our data set.
So, the data set consists of annotations to dash cam videos, and we do this using the PED Analyze Annotator tool that Mina went over. Now, the annotations use behavior tags from the PED Analyze documentation, hence the importance of establishing this ontology. So, in the process of data set development, there are 4 types of annotations to be aware of. The first of which is pedestrian behavior. One such as the car hood hopper, jaywalking, or other erratic pedestrian behaviors to be cautious of. Secondly is vehicle behavior, akin to the sidewalk example Swell went over. Thirdly are the environmental conditions, which actually play a major role in that Dr. Muqtadir discovered in his past research, and that's why we examine this so closely. And fourthly are the archetypes, which are the series of behaviors that we went over earlier. And the overall importance is that these annotations will serve as the data set for future autonomous vehicle development.
Now we jump to the future works. The future works we're trying to do is we're trying to use the tool to create a larger data set. With that data set will be used to analyze pedestrian archetype and behavior distributions. We are also trying to create a simulation that can model such unpredictable pedestrian to test against AVs, as we can see in the table.
So, in conclusion, the impact of this research is multifold. Because the AVs utilize datasets currently composed of subjective annotations. However, the introduction of a standardized terminology will streamline this training, as the dataset to be used by researchers and autonomous vehicle companies that's meant for creating simulations that Ritvik went over, and that dataset will now have standardized annotations to go off of, rather than this subjective, confusing form. And as AVs eventually improve, they will build a greater trust among the public.
The takeaways and lessons learned while working on this project along with my teammates are that pedestrians are very unpredictable, which poses many challenges towards vehicles. Also, pedestrian behavior modeling research is very important because not many people take pedestrian behaviors into consideration. They usually go with the vehicle behaviors.
We have the acknowledgements here. Thanks to UC Santa Cruz and SIP Program Director Professor Raja Gothagurto and Assistant Director Anant Lalia. Thanks to our mentor Dr. Ghulam Muqtadir and past project interns. Thank you. Does anyone have any questions?
Any quick question? That's it.